Hey there, everybody. My name is Ryan Schul. Welcome to my analytics channel. So today I want to talk about dynamic credit line management, and I'm going to show you an example of how certain credit-worthy customers can be approved for higher credit limits, and if the person is deemed to be a risk to the lending institution, how credit can be diminished or your credit limit can be reduced. Okay, so we're going to look at dynamic credit management, try to predict future utilization for each account. Okay, so account by account, it's not across the board, it's by individual, and we're going to build synthetic portfolios of data by creating a true future utilization target for each customer. Remember, this is customer by customer basis. Train a machine learning model to predict future use or application of credit, or granting higher privileges to access more credit, or to reduce the credit threshold that you are allocated for or that you are approved for, right? And basically to derive a simple limit policy, increase credit limit, keep it the same, or decrease the limit. Okay, so let's go ahead and look at a data sample right here. I am going to create a synthetic data set here showing customers, age of the customer, monthly income, credit score, and number of months that the person has been a customer. Now, I don't have actual credit data. You can look at some of these things on Kaggle. There's a couple things on the internet. I've already used these in some of my other videos. I've got quite an extensive library at this point. I think like 460 videos or something I've done. A lot of these are on credit. So I've used most of the major public sources. I don't want to be redundant and repetitive and go back to those, so I'm going to just create a synthetic data set right here, but it should be pretty practical, very realistic, and it should suit the need here and illustrate the point that I'm trying to create. So what do we need? First of all, credit limit. Balance on the credit card. Does the person usually have a low balance, high balance, in between, something like that, or no balance? Are they paid off every month? These are the things that we need to know to assess. Should we increase the credit limit or decrease it, or just keep it the same? And then overall current balance, and then credit limit. This is going to give us the utilization of the current amount that the person has available, right? The amount that they can tap into. So we're going to look at the average spend over 3 months. Does a person pay on time? Yes or no? What's the ratio, or what's the probability of paying on time if they do pay on time? Are there any missed payments? Are there over limits, exceeding credit limits? Are you getting too much credit in the last 12 months or not, right? So we're looking for risk exposures. We're looking for people that use credit very responsibly versus people that create headaches for the bank because they're very irrational with whatever kind of credit that they are approved for. So these are the types of things that we need to analyze, right? We see this in the data frame right here. Control Enter to refresh the cell, and we see the tenure in months, the current limit, the balance, average spending in 3 months. Is the person paying on time? Yes or no? Is it mostly on time? 90% of the time paying on time? I would probably fall into that bucket. I'm not 100%. It used to be 100% before COVID. After COVID, everything got jammed up like nobody could even imagine just a few years ago. Is there any missed payments in the last 12 months, over limit, exceeded in the last 12 months, and months since last increase, right? So again, the credit limit can be dynamic. It can increase, it can be decreased if the bank or the lending institution, doesn't even have to be a bank, it can be a credit union, it could be a credit card company, right? If they deem this to be a threat or high risk, then they will reduce the credit limit that you have access to. Okay, so we're going to take some of these features that I just discussed and assign a weighting to these, and go ahead and, based on the different feature, try to customize this to be able to make an estimate for how much credit can be increased or decreased, right? So we have the utilization based on current use, right? The trend over time, any missed payments, over limit, last 12 months. So we're going to take all of this into account, but that's de minimis right here. It's only 5% change if there was an over limit, use of credit, missed payments, 10%. We're really focusing on these types of things. So in total trend, is it increasing or is it decreasing? Or utilization, sorry, is it increasing 1 or is it decreasing -1? And the utilization. What is it currently right now? So what's the person using right now? Is it increasing over time? Do they need a higher threshold for credit and they should be approved for more? Or is it decreasing over time and the person never even comes close to the threshold? So maybe we should just decrease it because it doesn't matter anyway. They're not even going to use what they have been given. So that's the assumption here. Let me control enter to run the cell. So utilization current, they're using about half the credit. This is only 18, so this is pretty small. This is close to half, about 40%, and pretty small, right? So these people are really not using a lot of credit. This is actually decreasing. The utilization trend is decreasing, using less and less over time. Maybe this person was 65, 75%. Now they're down to 55. Maybe this was over 50%. Now it's decreasing, right? Thus the -1. And payment on time, most of the time, yeah, pretty much all the time, most of the time, almost all the time. This is a little bit more than half. So this guy is not really paying on time. He is using credit more aggressively, right? So his limit might be increased, okay? Missed payments in 12 months, they had 1, 2, 0, 0, 0. So fine over here, utilization in 6 months, is this true or not? These are all probabilities, right? So up to 1.0 would be perfect and 0 would be none. And high utilization in 6 months, so they're all zeros, right? So I'm not using a whole lot of credit. So let's go ahead build our first model here. Okay, so we have the independent features here: age, income, monthly, so on and so forth. Missed payments last 12 months. Is there any? Is there none? That's what we want to know. Over limit last 12 months. Months since last increase. And utilization trend. Is this up or down? So these are all independent features. I have hundreds of videos on my channel now describing how this works. This is an X variable, independent features. These all have a dependent influence on the dependent variable. This is the target variable. That's what we're trying to predict. And this is a regression problem. We can tell because this is numeric. Anything that's numeric, over here, everything is numeric. Over here, literally everything is numeric. There's no labels. A label would be something like high, medium, low, things like hot, cold, things like these are labels. They describe something. Large, medium, small would be the size of clothes. These are labels. Anything that would have a label can be categorized as a classification type of problem. Anything that's numeric is really a regression type of problem. So we're going to use a regressor over here, random forest regressor. We have a few hyperparameters that we can use to train a regressor. We're going to train the regressor here with ytrain, regressor, and xtrain. Fit the model and use this to make predictions. Y predict regression goes down here. So we have the R squared and the MAE. This is the mean average error. So if I run this, ideally we want to see a higher R squared, close to 1.0 would be great. Has to be at least 0.7 or higher to increase or to continue with the analysis. I see 0.87 here, so it's pretty good. This is meaning about 87% of the time the model is making correct predictions into the future. About 13% of the time it's making mistakes, but 87 is pretty decent. That would be basically a B+. We could assign a B+ rating to this regression model, and it's pretty accurate. It's doing what it's supposed to do, okay? Mean average error is 0.03. About 3% of the time it makes a mistake, and about 87% of the time the XY coordinates line up with the regression line. This is the best fit line, so we're 87% accurate right here, okay? So that looks fine. And we're trying to predict until future 6-month prediction. So that is going to go over here. That's what we're trying to predict based on the regression model that we just set up and ran. So the regression prediction is predicting this. Utilization in 6 months predict. So they're going to use about 47%, 44%, 42%, 50%, and 43% utilization. Okay, so let's keep going here. Control Enter to run this cell. If credit score greater than 720 and row payments on time or on time greater than 97 and no missed payments, then this is low risk. Okay, if credit score is greater than 650 and payments on time is greater than 0.9, then we have medium risk. Otherwise, high risk. Okay, so this is a pretty tight, pretty high level, high bar to reach type of credit scoring or credit scoring mechanism, and we just want to understand like how likely is this person to be risky if we increase the credit limit. So this has a medium level risk. This is high risk. Why is this high? Because credit score is greater than or less than 650. Where's the credit score? Let's go over here. Credit score is less than 650 and payments on time. Ratio is less than 0.9. So payment on time ratio 0.7, okay, less than 0.9, and credit score is less than 650. Where's my credit score over here? Credit score. Oh, either of one of these has to be true, right? So the credit score is greater than 650, but payments on time is 0.74, so it's a high risk. Let's find another high risk. 0.79, so that is less than 9, so that is going to be high risk right there. What's the credit score? 17, okay. So 647 is under 650. He might have a high credit score just for that. Let's look at the payments on time. 0.58. So this is really high score, right? Or high risk. 647 credit score, and payments on time is just over 50%. So kind of a high risk there. So we are not going to increase the credit for this person. This is medium risk. Medium risk. These are high risk. So these guys will not get a credit increase. This might be increased dynamically. If this was a risk tier low, then almost most probably the credit would be increased for that person. Okay. So let's keep going with this. We have a total future 6-month prediction. If risk tier, so we have the risk here. Risk tier comes from right here, high, medium, low. We're looking at the riskiness and current limit comes from here. So the decision is keep the credit limit as a default unless this person has proven to be a low risk. Then we can increase the limit of credit access dynamically. If it's a high risk, then we are going to actually decrease the credit that the person has available. So decrease is going to take the current limit times 0.85, right? Multiply by less than 1.0, it's going to be a decrease. Increase 25%, we're going to take the credit limit, increase that by 1.25, and increase 10%, right? Credit limit times 1.0. Otherwise, just keep it the same. But if it's a risk, if utilization, where's my U here? Its whole feature 6-month predict. If that's greater than 0.90, then we're going to decrease the credit 15%. So multiply the current limit by 0.85. Okay, so let me run this. Control Enter to run it, and we will see limit decision and new limit. Okay, so if we go over here, limit decision increased by 10%. So new limit 1,650. So 16.5K. What was the original? So credit limit originally was probably 15. Yeah, credit limit is 15. Increased 15%, or increased 10% to 16.5. Keep the same. So these two, 20 and 15K. Originally it was 20, 15K. Okay, so the same limit. Increased 10%. So he was at 5,000. Now he's at 5,500. And this was keep. So he was at 2,000 originally. And why is this pretty low? Monthly income 3.9, so 4,000 per month, about 1,000 per week. Probably a lot of it is going to go to cover living expenses, food, rent, utilities, probably internet. You have to eat lunch, you have to eat dinner too. So just basic living expenses. 4,000 a month is not huge, especially in New York City. So this person might be high risk, and they're just going to keep the credit limit as is. They're not going to change it up or down. So next cell here, let's run it. Limit decision. We're looking at customer ID and size. The customer limit, we're taking the mean of this. The new limit is going to be the mean. The mean is the average, okay? Until future 6-month period, this is the mean again. And the average, once again, high utility, or high utilization, 6 months, keep the average. So Control Enter. We are doing an aggregation here just to look at the overall metrics of the whole group. So increase, about 38 people will get increases. 4,445 will be kept the same. And 517 will increase 10%. So we have 38 people going up 20% dynamically in terms of the credit limit. Average credit limit, average new credit limit, right? So before it's 8,300, 10.3 is a new. This is the same, 866, 866, and increase 10%, 7926 to 8719. Average utilization predicted, they're going to use about 48% of credit, 51, 52, and high utilization rate 0 and 0.0025 and 0. Okay, so looking pretty good here. Continuing on, or breaking out by risk tier and decision. So kind of same thing, but by risk tier: high, low, medium, medium, limit, decision, keep, increase, number of people. So most fall into that keep, the same. They're not gonna dynamically increase or decrease. That's fine. Let's look at a couple charts here. I always say a picture is worth 1,000 words. When we look at a chart or a plot of the data, it should be very obvious very quickly what's going on. So you don't have to spend lots and lots of time explaining to your key stakeholders or to your audience, whoever that may be, what's going on. They can look at a couple of graphs and understand that intuitively. So you have X equals utilization future 6-month predicted on the X-axis, and then the color is going to be the risk tier, so high, medium, low. And we are looking at different bins and then binning people according to how they roll up into these different bins. We're going to have 40 different bins and look at the distribution for each bin over time. So we have predicted utilization from 0.3 up to 0.75, so 75% of the credit will be utilized. In the lower cases is 0.3%, so I would probably fall on the left end of the spectrum. And you can see low, medium, high. I like these plotly charts. When you click on the color, it either adds it in or subtracts it out, right? And it can show you everything relative to the other groups. So we can see high, medium, and low all in one place. Pretty obvious, pretty intuitive what's going on there. So this is a box plot. Right? If you look closely, you can see this is a histogram. You always have plotly dot name of the chart or what the chart is intended to represent. So this is box plot. On the x-axis, you have risk tier. So we have medium, high, low. Y is the utilization over the utilization of the credit line as it's increased or decreased. So what percent of people are going to use what? You have the mean, median, mode, the maximum, upper, minimum, lower. So medium, high, and low are all kind of similar. High is a little bit higher in terms of utilization. Low is kind of lower, but you see tons and tons of overlap here. So these three aren't that different, right? Whether it's high, medium, or low, the utilization is going to be kind of the same. A little bit higher overall for high and a little bit lower overall for low, but lots of overlap, right? So the outcome is kind of similar for these three different categories. New versus old limit by risk tier. Again, we're doing the aggregation like you saw before. Right, this is aggregating by grouping by risk tier and limit decision, and we're doing aggregations for these. So we're looking at size, mean, this is size, average, and average. And again, grouping by limit decision and aggregating by the size, this is the count, and average. Okay, so kind of the same thing down here all over again. I think I just ran it, so I'm not going to redo it. So you have the risk tier, the number of people, the limit type, and then the average limit that the credit is increasing or not increasing. Okay, again, you have your color bars, the average new limit, average current limit. So these stay pretty much the same in the high risk category. In the low risk category, credit is actually increasing, right? Low risk, the credit card company can make more money if the person runs the card more and doesn't pay at the end of the month, right? They charge interest, so they can make more money. This is low risk, so the company is going to extend credit. This is medium risk right here, so the company will send a little more credit. In terms of the average limit, it's increasing not as much as the low risk people, but definitely increasing a little bit. And the high stays basically the same, right? I think exactly the same. So nothing changes for the high risk people, no extra credit, no extra limits. For the low risk people, we're going to bump it up with the expectation that we can charge interest and make more money for the lending institution. Medium, kind of the same, but just a slighter increase because the risk for this group is higher. So let me finish off here. We have, again, the aggregation grouping by risk tier and limit decision. We are looking at the number of customers here. This is going to be the heat map. We create the heat map right here, and I plotted the heat map right here, right, or display the heat map. Then I plot it. So this is my plotly density heat map. I'm looking at limit decision on the x-axis, so that's horizontal. The y is the risk tier, so that's vertical. You can see most of the customers fall into this limit decision keep, and the risk tier is high. So if it's high risk, they keep it the same. If the risk is low, limit decision, we still keep it. If it's medium, some of these we still keep the same. So there's an increase of 25% for the low risk people. We see this right here, 38 people get an increase in their credit limit. For medium and high, it's nothing. For increase 10%, it doesn't make sense just to increase the low risk people 10%. We boosted up 25%, right? So that is the middle block here in the x-axis. Boost up 25%, and 38 people get this boost, this benefit. For increasing 10%, this is medium risk, so that makes sense, right? So if you look at this heat map, it totally makes sense what's going on. Corresponds very well to this heat map and to this one too. So I think 1, 2, 3, they all jive, they all make sense. So what are we basically doing here? How can we increase credit limits dynamically based on the credit worthiness of the customer that owns this credit card, right? So for high risk individuals, we don't really change it. We don't change a credit that's high risk. We assume they probably won't pay off more money if they get a higher limit. They're just going to spend more and not pay, go into default, and then the bank loses, right? The bank might not get the money, or it's going to be very difficult to get that back. You don't want to be in that precarious situation. So you just keep these people that have high risk, keep them at the same risk tier, right? Don't increase the limit. That's what we see here. Prevent unexpected losses from overextension of credit. Identify safe opportunities to increase limit. We saw that from the low risk tier. We increased the limit for 38 people. Detect early warning signs of financial distress. Reduce probability of delinquency and defaults. Improve capital and regulatory efficiency. Deliver personalized credit offers. Reduce customer complaints about arbitrary limits or cuts. Now with this system, we can prove this is all based on data science, machine learning, nothing arbitrary whatsoever. It's all backed up by science, data science, computer science, math, and statistics, right? So if somebody tries to, complain or maybe even bring a frivolous lawsuit, you're not increasing my credit and I'm low risk. Well, maybe you're actually high risk, and that's why we're not increasing the credit, right? But you can substantiate and prove this beyond a reasonable doubt. Enable actionable real-time credit risk and monitoring, increase profitability while managing risk for the lending institution. Again, this can be a credit card company, a bank, credit union, who knows, Capital One, or Chase or Bank of America or Wells Fargo. It could be any of these guys, right? It doesn't matter. This is basically the methodology that they would follow. And they might have like little nuances and might be little curtailments or changes to exactly how they do the business and how they run the process. But I can pretty much guarantee this is essentially it. This is the essence of how to dynamically increase credit lines using predictions and limit setting based on the riskiness of the borrower, right? The risky profile is not going to increase in credit limit. The less risky person will get an increase dynamically, okay? So that's it, guys. I think we answered the question. The analysis looks pretty tight, pretty crisp, looks good overall. I'm going to save this, okay? Last saved 2 days ago. Let me save this. I don't think I made any major changes other than just running the blocks of code in these cells here. Saved 5 seconds ago. Okay, so that's good. I will download this copy right here and share that with you guys. So you have everything you need to do your own credit analysis on your own desktop or laptop, whatever you're running over there. And all you have to do is copy and paste these blocks of codes into your Jupyter notebook, and you're good to go, guys. You have everything you need to do the analysis and run it just like I did. Feel free to change things, whatever you want. Please subscribe to the channel. It helps me a lot. If you have some comments, post the comments there. I'll take a look at it. Other people might want to see what's on your mind too, so share your thoughts there. And then give me a thumbs up if you think the video is decent and it's worthy of a thumbs up, okay? It's free for you. It just takes a second, so go ahead and click that like button and click that subscription button. It helps me a lot, okay? We'll wrap it up. Thanks for your time, guys. Appreciate that, and I'll see you in the next video, which should come out pretty soon, maybe later today, maybe tomorrow.